Dear GATE aspirants, welcome to VEDAGATE Academy. In the previous discussion, we are done with frequency shifting. We saw some problems, simple problems. Let's go for time shifting. Yeah, our next discussion is time shifting. Next discussion is what, ma? Time shifting property. Time shifting. So in time domain, the signal is shifted. In time domain, the signal is shifted. Very important property. We learned that in time domain, if the signal is multiplied with the exponential, then in frequency domain the signal will be shifted. That is frequency shifting. But if the signal in time domain is shifted, what we are going to get in frequency domain? Let's see. Come on, brother, you have to understand. Execute here itself. Come on. Just if f of t is the signal, in time domain, its Laplace transform is what, ma? Its Laplace transform is f of s. Yes or not? Yes. Now, if the signal here is shifted by some a, then its Laplace transform is, yes, f of t Laplace is, come on, understand in this way. Forget about this a. What we have f of t. F of t Laplace is f of s. So, as it is shifted in time domain, in frequency domain, you are going to get a exponential, just reverse to frequency shifting. We'll discuss it that again, but with the same sign. What does it mean? In frequency shifting, in time domain, if there is exponential, yes, come on here. This is the signal in time domain, but to my signal, this is f of t I'm taking. To my signal, we are multiplying with exponential. What is the Laplace of u of t? 1 by s. As there is exponential multiplication, we need to shift the s term by how many units? 2 units, but with opposite sign. S plus 2 we got here. Here it is. In time domain, the signal is shifted. And in frequency domain, we are going to get exponential, but with the same sign. Let's see an example to get good clarity. Let's see an example, please. Come on, example. Yes, example. F of t is equal to u of t minus 2. What is f of s? He is asking about to find Laplace transform of the given signal. First of all, it's very simple, ma. Understand. U of t Laplace is what? 1 by s. That's it. 1 by s. See, this is the first step to do. Forget about this minus 2. U of t Laplace is 1 by s. As I have minus 2 here, we are going to get e power minus 2s. That much simple it is. Or let me give one example. One more example. F of s is equal to e power minus 2s by s square we have. He is asking about f of t. Inverse Laplace transform is asking. See, just by looking at the given problem, you have to understand in this way. Signal is 1 by s square, but it is having exponential in frequency domain. Exponential in frequency domain means what, brother? In time domain, it is having shifting. Exponential in time domain, shifting in frequency domain. Exponential in frequency domain, shifting in time domain. But the only change is sign. For frequency shifting in time domain, suppose e power minus 2t is there, you will get 1 by s plus 2. But here in frequency domain, you have e power minus 2s. In time domain, you are going to get minus 2 only. Means with the same sign. In frequency shifting, sign of that exponential will change. Means e power minus 2 is there, s plus 2 it will become. Here e power minus 2s is there. There we are going to get minus 2 only. Let us see. What is I can write the given f of s as e power minus 2s into 1 by s square. Yes, 1 by s square. 1 by s square I'll write first. 1 by s square. What is the Laplace of 1 by s square? T into u of t. T into u of t is the inverse Laplace. 1 by s square. But I have what? E power minus 2s. E power minus 2s means what? The signal in time domain got shifted by how many units? 2 units. 2 units. It is delayed or advanced? Delayed. By how many units? 2 units. So t has to be shifted. Is it done, brother? No. This u of t also must be shifted. All t variables. T, not t square, t cube or root t or t power 0.5. No. All t must be shifted with the same units. This is f of t. T minus 2 is a signal. U of t minus 2 is its a unit step. Okay. 1 by s square is t into u of t. 1 by s square is t into u of t. But as it is having exponential in frequency domain, in time domain, the variable t, independent variable t is got shifted. Therefore, t minus 2 into u of t minus 2. Some people will take the option as f of t is equal to t minus 2 into u of t. Some people will take the option as f of t minus 2 into u of t. This is absolutely wrong. All t variables of that signal must be shifted. All t variables means wherever t is there, that one you have to replace with t minus 2. Okay. Some people will take it as a t into u of t minus 2. This is also wrong. This is also wrong. Yeah. Some people will take just only t minus 2. This is absolutely wrong. Why? Because 1 by s square inverse Laplace is what? T into u of t. Without this u of t, it is meaningless. Why? Because t is a signal which is existing from minus infinity to plus infinity like this. This is t. But t into u of t is ramp. T into u of t is ramp whose Laplace is 1 by s square. So the same question we will discuss in another way. The same question we will discuss in another way. Yes, graphically I'll prove how all these answers are wrong. See, you might be getting one doubt. Sir, you wrote t minus 2 into u of t is wrong, t into u of t minus 2 is wrong, t minus 2 is also wrong. Then what is the correct answer? Yes, we wrote previously, that is t minus 2 into u of t minus 2 is correct. Sir, we have a doubt. How this is correct? Why these three are wrong? We want the proof. Let's go for an experiment by taking an example. Let's go for an experiment. I'm taking an example, please. I'm taking an example. Yeah, the question is like this. If f of t into, or let's take like this, if f of t is equal to t into u of t is the signal, yes, yeah, he's saying that he's having a signal f of t is equal to t into u of t. If the given f of t is shifted to the right side, right side shifting is what, ma? It is advanced or delay to the right side by 2 units, then the expression for shifted signal is dash. I'm giving the options. First option A is t minus 2 into u of t is the option A. Option B is t minus 2 in t minus 2. Option C is t into u of t minus 2. Option D is, come on here, ma. Option D is t minus 2 into u of t minus 2. Actually, previously we saw this problem. I told you that this is the answer. Remaining all are wrong. So here, what experiment we have to conduct? We have to conduct an experiment to prove A, B, C are wrong. A, B, C are wrong. For that, I'm going to take up like this. Yes, this is the proof what I'm going to take up. What are the signal we have taken? F of t is equal to t into u of t is the signal, brother. Yes or not? Come on, brother. F of t is equal to t into u of t is the signal what we taken. Let us draw it. Yes, let us draw it. We are drawing simply. This is the signal. We have to mark definitely all the axes. This is t. This is f of t. T and f of t. This is a 0 origin. That is a signal. What he is saying is this signal is shifted to the right side by how many units? 2 units. This particular signal is shifted to the right side by 2 units. Let us shift it. What I told you. If you want to shift any signal, just hold it and drag it to the right side by 2 units. That's it. Yes or not? Come on. What I am telling you here is hold the signal, drag it to the right side by 2 units. I am drawing the graph. Without having any expression, I am drawing the graph. Okay. It's a shifted version is, see, shifted version. I am naming it as shifted version. Right shifted signal. Yes. By how many units? 2 units. Its figure we will draw. Observe carefully. Its figure. This is T, boss. That is T. Yes. Come on. Then just hold it and drag to the right side by how many units? 2 units. This will be the signal. That's it. 2, 0. That's it. This is the signal. Just you hold it and drag it to the right side by 2 units. That's it. Means we have three expressions, A, B, and C. Let us draw the graph of A, B, and C. Check which one is suitable to this one. That will be the answer. So if A, B, C are not suitable, A, B, C are wrong, and check for D also. If D is suitable, yes, D is the answer. Let's take the first term. What is the first one we taken? T minus 2 into U of t. Let us draw T minus 2 into U of t. Let us draw T minus 2 into U of t. The first option is what my A is T minus 2 into U of t. So here I have two things, T minus 2 into U of t. I will draw T minus 2 and U of t separately. I will multiply, then I am going to get T minus 2 into U of t. Very simply we will do. Before we draw T minus 2, let us draw T first. Let us draw T first. Yes, T. What is T? Yes, T is very simple. T is like this. It's a straight line passing through origin. Just it is like f of t is equal to t, y is equal to mx. Okay, m is equal to 1 here, f of t is equal to t. This is f of t is equal to t. This is the graph of t. Yes, come on dear. Very simple. Just we are executing 10th class mathematics, not more than that. Okay. Now, what we need t minus 2. What I told you, if you want to shift any signal to the right side, take it and drag it to the right side by those many units. If you want left shifting or advancement, drag it to the left side by those many units. Now, I'm going to draw T minus 2. This will be T minus 2. Just a minimum. Yes, I'll draw T minus 2 also. Come on. This will be T minus 2. Just this will be T minus 2. This is point is 2. Yes or not? That is what? T minus 2. Now, what we need? We have to multiply. Yes, we have to multiply to this one. This is T minus 2, please. This is T minus 2. T minus 2 has to be multiplied with what? U of t into what? U of t. Into U of t. Observe here, brother, carefully. Into U of t. What is U of t? 1 or 0. Now, before 0, how much you have for U of t? 0. So, all this part will die. I am showing it here. All this part will die. So, up to here it will die. Okay. So, what I am going to get? This observe this green color waveform. This is T minus 2 into 1. How much we are going to get? The same blue color waveform from 0 onwards. Before 0 it is going to be 0. So equal to yes, we are getting like this. Observe, we are getting like this. Yes. So this is the answer. This is 2. This is T. Yes. This is the signal for T minus 2 into U of t. Yes or not? Yes. Does this is same as the obtained one? Yes. Does this is same as this one? No. Observe here. From 0 to 2, nothing we have here. But here, from 0 to 2, we have some magnitude. And there is some negative side, what you call the magnitude also. So, option A is wrong. Experimentally, we proved that option A is wrong. Let's go for option B. What is option B, ma? Option B is, option B is, what is option B? We are done with this one. This is wrong. Option B is only T minus 2. That is also wrong. Directly we can prove. How we can prove? Yeah, look at this. T minus 2. This is T minus 2. Does this is same as the answer what we got graphically? Does this is same as this one? No. Option B is also wrong. T minus 2 is also wrong. Yes, T minus 2 is also wrong. What we have the last option, not last but one option, T into U of T minus 2. Let us sketch this one. T into U of T minus 2. Yeah. Option C is what? T into U of T minus 2. What is the graph of T? Yes, this is the graph of T. That is, this is T. Yes, that is T. To this one, what we have to multiply? We have to multiply with U of T minus 2. U of T minus 2 means where the signal will start. That the magnitude 1 will start from t equal to 2 onwards. I told you, if you want to know where the signal is starting, make that bracket term equal to 0. T minus 2 is equal to 0. At t is equal to 2, it is going to start. Before t is equal to 2, what is the value? 0. From t equal to 2 onwards, its value is 1. Yes or not? Now, if you multiply these two, what we are going to get? We are going to get like this. Observe what we get. So here this is t equal to 2. Up to t equal to 2, what we have? 0. 0 and anything is what? 0. So we are getting like this. This is the signal what we got. This is a signal. Yes. This is 2. This is t. Does this is same as the answer what we got graphically? No. This is not correct. Observe here. Yes, this is what I have to get here. This is 0 here, at t is equal to 2, it is 0 here, but at t is equal to 2, it is having some magnitude. It is having some magnitude. Yes, yes or not? This is wrong. Option C is also wrong. What we are left with finally, the last option, option D, is t minus 2 into u of t minus 2. After completion of this one, I will be giving one what you call conclusion, a very good conclusion. Let's see, first of all, draw this one. T minus 2 into u of t minus 2. T minus 2. Yes or not? We will be drawing. Observe here carefully. Observe here, all of you. Yes, this is t axis. Come on. We will be drawing. This is t, boss. This is t. This is t minus 2. You know it very well. How to get t minus 2? Drag the signal to the right side by 2 units. Just hold it and drag it. This is 0. This is t. This is t minus 2. So this one, what I have to multiply? I have to multiply with what, ma? U of t minus 2. This is 2. This is 1. Yes, this is u of t minus 2. Signal u of t minus 2. This is t. Now what I am going to get in the result? In the result, what I am going to get? Observe here. In the result, at t is equal to 2, what is this value? 0. So this waveform, this part, we are going to get from 2 onwards. Same. What about this part? What about this part? Let me show that part. Let me show that part. What about this part? This part will disappear because before t is equal to 0, what is the value we have for u of t minus 2? 0. 0 into anything is what? 0. So the answer what we get here is like this. This is 2. This is 0. Yes, this is t minus 2 into u of t minus 2. Yes or not? So which option is correct? Option D is correct. What the point here is, shifting means not just shifting only the signal, its associated step signal also must be shifted by the same units. Means if I have a signal f of t, if I have a signal f of t into u of t, yes, if I have a signal f of t into u of t, if this signal is passed through a device which is providing some time delay, then some time delay, that time delay, suppose say 2 seconds, that time delay is 2 seconds, say, then the obtained signal will be f of t minus 2 into u of t minus 2. Yeah, this total is signal, not f of t. If the f of t is shifted, then u of t also must be shifted with the same units. This is the correct shifted version of the given signal. We have some problems in previous gate on the same concept with some confusing options. That's why it is very much required to get good clarity. Come on, brother, you are able to understand or not? Yes, come on. Here, with this, we are done with frequency shifting. We are done with impulse, step, ramp, parabolic, exponential. From exponential, we understood about frequency shifting, time shifting, okay, the correct way of time shifting, and all these things we learned. And one of the important signal that we are left with is a sinusoidal signal. Yes, sinusoidal signal, how it is represented, all these things, many things we are going to discuss about. What is the difference between sine and cos? It's a Laplace, inverse Laplace. Okay, after that, a lot of things we are going to discuss. Come on. The next signal I'm going to take up is what? Sinusoidal signal. Come on. Our heading is sinusoidal signal. Entire frequency response, I told you from 7th chapter onwards, introduction to frequency response, Bode, Polar, Nyquist, up to then completely the analysis will be frequency response analysis, where I am exciting my system always with sin omega t, sinusoidal signal, not sin omega t, exactly, sinusoidal signal, and I am varying frequency omega from 0 to infinity. There, this plays very important role. Okay, come on here, sinusoidal signal. Yes, sinusoidal signal. So how it is represented mathematically? So x of t is equal to a sine, yes, omega t plus some theta. That theta may be 0, may be any value. Suppose if theta is equal to 90, then that sine will become cos. Frankly speaking, there is no difference between sine and cos. There is no difference between sine and cos. See, what is the difference between sine and cos? Cos is the one which is advanced when compared to sine by 90 degrees. 90 degrees. Yes. What does it mean by degrees also? I will tell you. Let me define about one term. A is what? A is the peak magnitude of the given signal. peak magnitude means a highest possible value. See, what is the highest possible value of that given expression? Yes, I want the answer from you, boss. Very simple. Highest possible value of that expression. Yeah. What is the highest possible value of sine omega t plus theta? That omega t plus theta may be any value, whatever it is. But how much is the maximum value of sine is +1. Minimum value of sine is what? -1, not 0. Some people, without thinking instantaneously, they give the answer as 0. It is not 0, please. It is -1. The maximum possible value or peak amplitude or peak magnitude is a omega is angular frequency. Omega is what? Angular frequency. Come on here. Omega is angular frequency. Units are very important. Angular frequency. What are the units of omega? Radians per second. Radians per second. So theta is some phase shift, either it is 0 or positive or negative. What does it mean by theta? What are the units of this omega t? That is in radians. If omega units are radians per second, omega into t, radians, second will get cancelled, or left the radians. Radians plus radians. So this omega t is also angle if you substitute omega and t. So this is about its description. We have to draw its figure. We have to draw its figure. Before we draw its waveform, not figure, please. Omega is equal to 2 pi f. Omega equal to 2 pi f, where f is normal frequency in hertz. Frequency in hertz. What is frequency? Number of cycles per second. I'll write here number of cycles per second. Cycles per second. Yes, number of cycles per second. Now what we have to understand is, what does it mean by angle? What does it mean by angle? 30 degrees, 40 degrees, 60 degrees, 100 degrees, 120, 360. What does it mean by angle? So many people don't know about leading and lagging and angle and all these things. Suppose first, I told you many times that human understandable domain is time domain. If I say something about in terms of seconds or minutes or hours, I'm able to understand. Suppose there is one person who is running ahead of me. So you can say like this, that person is 2 minutes ahead of this person, or 2 meters ahead of this person, but not some degrees, right? But not some degrees. Why I am giving this example? Suppose if I take an example, RL network with sinusoidal input voltage in AC analysis. In networks, you might saw this one. In RL network, current lags the source voltage. Current lags the source voltage by some angle. Current lagging behind voltage means what? Current lagging behind voltage means what? Let us take that. Let me take that example. Then I'll go for sinusoidal. Let me draw this one. Yes, this is R. This is L. This is the input signal, sinusoidal. Yes. If I'm not giving this sinusoidal signal, if I'm giving DC here, this L will be L only. In transient analysis, L will be L, but in AC analysis, L will be represented with omega L, whose units are ohms. You might learn in network analysis, this resistance is in ohms. In entire network analysis, we can divide the entire network analysis into two parts: sinusoidal steady state analysis, SQBA analysis, and transient analysis. Steady state analysis means there are no sudden changes. Gradually, the input or output is changing. Transient analysis means change of study of sudden change. You are studying sudden change of inputs in the circuit, then that is called as transient analysis. Suppose if I am giving DC here, DC means suppose a 5 volts that is getting suddenly applied. Here it is x of t is sin omega t. Suppose x of t is equal to, I write it as sin omega t, and imagine that the switch is closed at t is equal to 0. Then there are no transients. We can speak. There are a lot of things to discuss about AC transients. You might discuss already in AC analysis or in transients in network analysis. That's why I'm not discussing all those things. Here my main intention is to understand about leading, lagging. What does it mean by degrees? 30 degrees, 60 degrees, 90 degrees is like that. That is our main intention here. Please come on here. Now the current in this circuit is I of t. If you draw the phasor diagram, this is the source voltage V of t. We wrote it as x of t here. Let's write it as V of t. Yes, this is V of t is equal to sin omega t. That is voltage phasor. We know very well that current in RL network lags by theta. Current in RL network lags by theta compared to the applied voltage. Yes, this is I of t. This is our reference. This is theta. This is theta. Yes or not? Yes, sir. What is theta? Theta is impedance angle. Theta is impedance angle. We know VR of t will be, voltage across the resistor will be in phase with the current through the circuit. In phase with the current through the circuit. Therefore, this is VR of t. Maybe the magnitude is more than I of t or less than I of t. If R is less than 1, less than I of t. If R is more than 1, more than I of t. So this length of the vector is not a matter here. Why? Because we did not take in value of R. Therefore, I am taking less than R, less than I of t or more than I of t. It does not make any sense here. Now, what is VL of t? VL of t is equal to j omega L into I of t. Yes, j omega L into I of t. This j stands for what? Plus 90 degrees. Plus 90 degrees, that j stands for. When compared to I of t, I of t is having some angle theta to the lagging. To the lagging. This is 0 degrees. Reference, this is taken as reference, or it is also taken as what? 0 degrees. Okay. When compared to that, this is lagging by theta degrees. Theta is equal to tan inverse of omega L by R. You might did all these things in your network. That's why just I'm not giving all the complete details. I'm explaining about the angles only. Okay. Theta is equal to what? Tan inverse of omega L by R. This is called as impedance angle. Now, j omega L. What is voltage formula? Voltage is equal to impedance into current. What is the impedance of this one? Omega L. But JXL, one J will get extra for inductor. For capacitor, minus 1 by J XC, minus 1 by J XC, or 1 by J, sorry, XC is equal to 1 by omega C, XC is equal to 1 by omega C. Total impedance will be minus J by omega C, minus J by omega C. For capacitor, you will get minus J, for inductor, you will get plus J. You might learn all these derivations in your network analysis. So plus J is there. This is already having some theta. Theta plus 90. Theta plus 90 means when compared to this one, that current will be that current or voltage across inductor. Voltage across inductor. This is 90 degrees ahead. Means when compared to current, yes, this is the current. When compared to current, that voltage across inductor will be 90 degrees in leading. Yes, this 90 degrees is extra. 90 degrees is extra. Anyhow, this omega L is constant. So this is the phasor diagram. This is the phasor diagram. If you have any doubt in this analysis, you can ask any doubt at any point of time. Okay. This is voltage across inductor. If I take this one as a reference, V of t as a reference, current and voltage across resistor are in lagging, whereas voltage across inductor is leading. What does it mean by this leading and lagging? What does it mean by this leading and lagging? We have to understand. See, I'll tell you one thing. Current lags voltage by 30 degrees, suppose say. What you understood? How do you understood? What does it mean by? See, this is an interview question asked in Bark. What does it mean by current lags voltage by 30 degrees? Yes, this is an explanation. Please understand. First of all, we need to understand what does it mean by angle? What does it mean by angle? You tell me, what is F? F is the frequency. F is the frequency. Come on, frequency. F is called as what? Frequency. Number of cycles per second. F is a frequency. Yes. Frequency, that is number of cycles per second. In 1 second, how many number of cycles the waveform is making? What is the frequency? I'm taking example frequency of 50 Hertz. Generally in India, frequency is 50 Hertz. In US and other countries, mostly. See, I'll tell you one thing about frequency. Total world is having two different kinds of frequencies. US based countries are all having 60 Hertz. UK based countries, or India was ruled by Britishers. Britishers means UK. Their frequency is 50 Hertz. Therefore, our frequency is also 50 Hertz. US based countries in the world, all countries are having 60 Hertz. Okay, so come on, F is equal to 50 Hertz. What does it mean by that? In 1 cycle, in 1 second. See, 50 Hertz means what? 50 Hertz, or it can be written as 50 cycles per second. 50 cycles per 1 second. Within 1 second, our current or voltage is making how many cycles? 50 cycles. Now you tell me, 1 cycle means how many degrees? 1 cycle means how many degrees? 1 cycle means how many degrees, ma? 360 degrees. Yes. 1 full cycle. Yes, I'm drawing the cycle. Yes, sinusoidal waveform. Let us take it as omega t. Now this is some f of t. I'm drawing the waveform. Observe here. Yeah, I drawn here how many cycles? 2 cycles. So this is 0. This is 180 degrees or pi radians. This is 360 degrees, or this is 540. That is 720. You can mark it. Not a matter. This is 0, pi, 2 pi, 3 pi, 4 pi. Yes or not? One full cycle means how many degrees? This is one full cycle, please. This is one full cycle. One full cycle means how many degrees? 360 degrees. One full cycle means how many degrees, ma? 360 degrees. Now the actual concept comes here. Understand? See, if you go to any interviews like BART, ISRO, DRDO, this type of questions will be asked. Okay, one full cycle means how many degrees? 360 degrees. See, 50 hertz means what? 50 cycles for 1 second. In 1 second, how many cycles? 50 cycles. Then my question is, how much is the time taken to complete one full cycle? See, 50 cycles in 1 second, 50 cycles in 1 second. This is a number of cycles. This is time t. This is time t. Then how much is the time taken? How much is the time taken to complete one full cycle? To complete one full cycle. One point what we understood previously is one full cycle means what we understood? 360 degrees. Means our current variation from 0 to peak, 0, negative peak and 0 to make this one full cycle. How many degrees it is taking? 360 degrees. 360 degrees. For 50 cycles, for completion of 50 cycles, how much time it is taking? 1 second. Time in seconds. Yes, let me write here. This is, yes, here I'll write clearly. Let's write clearly, please. Let's take in the form of table. Let's take in the form of table. Here, number of cycles. Number of cycles. Here, time taken in seconds. Time taken in seconds. Come on here how many cycles we are taking? 50 cycles. Within how much time? 1 second. Sir, who is giving this answer? Who is giving this one 50 cycles in 1 second? Our frequency, our household frequency in India is 50 hertz. 50 cycles per 1 second. Okay. But what I want to know how much is the time taken for 1 cycle. For 1 cycle, I want to know how much is the time taken. Then just cross multiplication and all these things. So this is t if you take. So 50t equal to 1. That is time taken for 1 cycle is equal to 1 by 50. How much it is equal to? 0.02. This is 20 milliseconds. This is very, very important. Yes, this is very, very important. Yeah, in what way it is important? How much is the time taken for one full cycle? So I'm writing here time taken. Yes, time taken to complete one full cycle. Yes, come on here. One full cycle is how many, ma? 20 milliseconds. 20 milliseconds. Now, what is the analogy? What we got? One full cycle means what we got? One full cycle means what? 360 degrees. One full cycle means 360 degrees. Means with respect to 50 hertz. By keeping that in mind, okay, 50 hertz means one full cycle means 360 degrees or 20 milliseconds. I can write by keeping 50 hertz, or if the frequency is 50 hertz, I can write like this. If the frequency is 50 hertz, come on, man. If the frequency is 50 hertz, yes, 360 degrees means how many milliseconds? 20 milliseconds. Come on here. I'll show you in the graph. Too. Yeah. Here we wrote omega t. Omega t means what? Or angle. This is theta. Omega t or angle theta. Suppose the same axis you are taking it as t. I'll draw the waveform. Come on here. Answer first. 360 degrees means 20 milliseconds. 180 degrees means how many milliseconds? Come on dear. You have to answer. 10 milliseconds. 90 degrees, how many milliseconds? 5 milliseconds. Suppose if I say current lags the voltage by 90, means what? current is starting 5 milliseconds after the voltage is started. Either you take starting point or peak point or negative peak point. The same points you have to compare. Either all maximum values or all minimum values or zeros you have to compare, but not one maximum with another minimum or one maximum with another zero. Means I can tell you like this. See, let's understand the point. Current lags the voltage by what do you call it, 90 degrees. Let's understand this statement. Very good statement. Okay, so this question is asked for a student in IISc Bangalore for interview. Okay, for MTech interview. The question is this one. Explain current lags voltage by 90 degrees. Take f is equal to 50 hertz. The interviewer mentioned that the frequency is 50 hertz. The operating frequency is 50 hertz. Take f is equal to 50 hertz. He asked, please explain this one. Student in the first point he confused. Current lags voltage by 90 degrees. Yes, it's lags by voltage by 90 degrees. If you take ideal inductor, in an ideal inductor, current through inductor lags the voltage across inductor by 90 degrees. That's done. But the interviewer not exactly expecting that. What does it mean by 90 degrees? If 50 hertz is there, 90 degrees means some what? 5 milliseconds. Means if I draw the graph of it, this is the explanation. Yes, I'm taking t here instead of omega t. I'm taking t there instead of omega t. First, let me draw voltage. Come on here. So this is the voltage. By assuming that the switch is closed at t is equal to 0 and the voltage is getting into effect at t is equal to 0. Yes, this is voltage. Okay, the current has to start where? Current has to start after 90 degrees. Yes, this is 90. In degrees it is 90, but with respect to 50 hertz, what is this? This is 20 milliseconds. Time in seconds. I'm mentioning here. This is what, 10 milli. This is what? 5 milliseconds. Now, where the current starts? The current starts here. The current will start here. Observe here, current will start here. Yes, current will start here in this way. Yes, come on, you have to understand in this way. Yes, current will go like this. Yes, this is the complete waveform. This is a V of t, this is a I of t. Now, we have to compare either maximums or minimums or zeros. Now, this is the maximum value. This is the maximum value of voltage. Where it became maximum value at t is equal to 5 milliseconds. Where the current is becoming maximum at t is equal to what? 10 milliseconds. Yes or not? The time difference between voltage becoming maximum and current becoming maximum is 5, and current is becoming maximum after voltage becoming how many milliseconds? 5 milliseconds. This is what does it mean by lagging. Okay, you see the minimum also. So if you observe minimum, yeah, here it is becoming minimum, right? Here it is becoming minimum. I'm taking, see, in any cycle you can take. Here, what is this? 15 milliseconds. Where current is becoming minimum at 20th millisecond. How many milliseconds the current minimum is lagging when compared to voltage minimum? 5 milliseconds. In this way, we have to understand angle means nothing but time. But how much time it is exactly will be given by the frequency, operating frequency. If the operating frequency is 60 hertz, it is not going to be 20 milliseconds. Answer will be 1 by 60. You have to calculate, and one full cycle means 1 by 60. One cycle means how much you have to calculate. Yes or not? Yes. So this is what about angle, leading, lagging. Okay, leading means it start. See, the same statement can be understood in this way. Voltage leads current by 90 degrees. Yes, very much yes. Current lags voltage by 90 is correct, or voltage leads current by 90 is also correct. Both are correct. Leading, how to explain? When compared to current, voltage is becoming maximum 5 milliseconds earlier. Yes, that's why it is called as a leading or advanced. Yes or not? Yes. Now, this is about the concept of angle. Omega t may be in radians or degrees. You know very well how to convert from degrees to radians or radians to degrees. This is very important. When we encounter the frequency response, they're finding gain margin, phase margin. At that point of time, many students will commit a mistake here. What is that mistake committed by students is, see, you might see e power minus j pi by 2. How to write e power minus j theta? You know very well. E power j theta is equal to s cos theta plus j sin theta. Intermediate mathematics, brother, very simple. J sin theta. Yes or not? Now I want its angle. I want its angle or not angle. See, what is the angle from this one? You are going to get pi by 2. See, the theta is how much? From this one theta, how much you are going to get? Pi by 2. This is correct. See, this is correct, but what is not correct? Writing e power minus j 90 is wrong. You should not write like this. E power minus j pi by 2 is correct, but e power minus j 90 is wrong. Yes or not? Yes. Now, see, I'll tell you one thing. People will write in this way sometimes. People will write in this way sometimes. We should not write there. When we encounter the frequency response at that point of time, I will tell you exactly what is the mistake you're committing when we are solving that problem. But till then, you remember this e power minus j pi by 2. See, when it is exponential power, the angle must be in terms of radians, not in terms of degrees. Please do remember this point. Okay. Now, we are in sinusoidal expansion. Let us draw that a sin omega t. A sin omega t plus theta. I am taking theta is equal to 0. No issues. I am taking theta is equal to 0. Come on here. I am drawing the waveform. This is omega t. I'll take. If I am taking omega t, the units of this axis are what? Radians or degrees. If I am taking this one as t, then units of this axis are what? T. Either you take any one of those two, waveform is not going to change. Units of this axis are going to change. Okay. Now this is 0. Now this is 0. Let us draw the waveform. I am taking theta equal to 0. We taken x of t is equal to a sin omega t plus theta. Go back and just recollect. We taken x of t is equal to a into sin of omega t plus theta. We are taking theta equal to 0 for the simplicity purpose. That's it. You can take theta equal to 30, 40, 60, 180, 270, whatever you want you can take. Not a matter. Yes. Now this is the waveform I am drawing. Yes. Yeah. What is this value? This value is plus a. This is x of t, what we taken, sinusoidal signal. This is minus a. And mark this. All these basics are very, very important, brother. If you are not having good command, good clarity on these basics, you cannot touch a control system problem. If you are good at these things, control system can be understood very easily. Basics are very, very, very important for learning control system. Okay. So here, what is this? I can write it as 180 degrees or pi radians. This is 2 pi. We won't write it as radians. There itself we will mention in radians, please. In radians. Here itself will mention it as what? Radians. Okay. Now pi, 2 pi. What this one will be? 3 pi. What this one will be? 3 pi. One full cycle means yes, here to here. 360 degrees is taken as one full cycle. 360 degrees is taken as one full cycle. Suppose if this is t in second. What I should write here? Here this will be pi by omega, or this will be what ma? 2 pi by omega, or this will be what ma? 3 pi by omega. Please do remember, in examination everyone will do the procedure, but they won't observe this as given as omega t or t. There you will commit a mistake, you will get negative marking. That's why having good clarity what that is given on x-axis, this independent variable omega t or t, that is very important to recognize. Okay, this is waveform. This is a sinusoidal waveform. Now what we are interested in? We are interested in its Laplace transform. What are the advantages of this sign, and all these things we will be discussing in frequency response analysis. But before that, I want cos also. Cos is the one. Yes, tell me. Cos is the one which is having, come on, 90 degrees advancement when compared to sine, right? 90 degrees advancement means with respect to 50 Hz, how many milliseconds? 5 milliseconds. With respect to 50 Hz only, please. That you have to mark it with respect to 50 Hz only. Now come on here. Cos is the one. This is the cos signal. Means if I draw reference axis here. If I take this one as 0, and this is our x of t, then the signal can be written as cos. That's it. Yes or not? Just change the reference axis to this side by 90 degrees. Then you're going to get a cos waveform. Cos is sine. See, as far as I am concerned, sine and cos are both the same, except the advancement of 90 degrees, except the advancement of 90 degrees. Sine and cos both are same, shape wise, frequency wise, everything wise both are same. Suppose if I'm taking a sin omega t, a cos omega t, both are same with respect to me. Just cos is 5 milliseconds with respect to 50 Hz is ahead, or cos is 90 degrees ahead when compared to sine. That's it, not more than that. Okay, now we want to find its Laplace transform. We want to find its Laplace transform. Come on here, Laplace transform of a sine omega t is dash. A sine omega t is dash. Answer please. You have to answer. Answer is does not exist. Why? Sine omega t is bilateral signal or unilateral signal? Bilateral. If you observe, this sinusoidal signal is existing from minus infinity to plus infinity. While you are finding Laplace transform, you have to take integration limit from minus infinity to plus infinity. When you take the integration limit, lower limit minus infinity, e power of minus s into minus infinity will become e power infinity. How much it is infinity? The answer is diverging. Therefore, Laplace transform does not exist. Then for which one Laplace transform will exist? Into u of t. Into u of t is there. Then Laplace transform will exist. Laplace transform will exist. Proof. All these things you will learn in signals and systems. Just here we are going to take its formula. Remember this formula, a into. If you want proof, you can do it also. Do this integration. Integral 0 to infinity. F of t is what? A sine omega t into e power minus st dt. You do it, it definitely will be getting. Okay. We are not interested in doing integrations. As you are very good at integrations, you can do it. A into. Yes, you can remember this way. You have to remember in this way. That is, what is the frequency, angular frequency we have? Omega by, yes, s square plus that frequency square. Yes, this is the formula. Laplace transform of a sin omega t. A is the magnitude, you can throw it outside. Then what is the Laplace transform of sin omega t? Omega by s square plus omega square. Omega by frequency by s square plus frequency square. Now come on here. An example I'm taking. That is first one. What is Laplace transform of sine 3t? Suppose if I ask sine 3t, what is the answer? Come on, brother. Does not exist. Why? Because sine 3t is a signal which is existing from minus infinity to plus infinity. If I keep here into u of t, yes, it will exist. Then what is the answer? Please do understand. What is the frequency? 3. Medium frequency omega by s square plus omega square. That is 3 by s square plus 9. 3 by s square plus 9. It's very important to understand and remember. Then only we are in a position to execute. Okay. Now, second question is, the second question I'm going to take up is, second question, Laplace transform of, if I say sine, or before going to the second example, let me do the Laplace transform of cos also. See, this is important to remember. This is also important to remember. Laplace transform of a cos omega t is how much? This also does not exist. Why? Cos omega t also varying from, existing from where to where? Minus infinity to plus infinity. If there is u of t, then it exists. Now keep a outside. For cos, it will be s by s square plus omega square. That is only the difference between sine and cos. If you observe, see, observations are very important for us. Observations are very important. Now I'm keeping this in a box. So this is a formula. This is the formula, and this is also a formula. Please do remember those two formulae. The only difference between sine and cos is a numerator. If the numerator is having a s square term and a constant s term is missing, then definitely it might be a sine or cos. Yeah, please remember my way of approach towards Laplace. This will be the easiest shortcut method to get inverse Laplace transforms with respect to control systems. Just by looking at the question, we'll answer it. Okay, definitely you have to adapt these methods only. Okay, if you have any short method than this, you can adapt that, but this is a short method what I feel. If you have any method, you can follow that, but do not follow any method longer than this. In the denominator, there is s square term and only constant. S term is missing, only s square and constant. Definitely either it is sine or cos. How to decide whether it is sine or cos? Look at the denominator, brother. If the numerator, brother. If the numerator is constant, that is sine. If the numerator is having s term, that is cos. Let us see some problems. Then you'll get in complete clarity. Yes, example. Let me take some examples first of Laplace. Then we go for inverse Laplace. Yes. First example I'm going to take up is Laplace transform of 2 cos 2t into u of t. 2 cos 2t into u of t. How much you're going to get, boss? 2. 2 is outside. Yes, 2 is outside. Cos 2t. Cos means, first of all, denominator. Denominator is what? s square plus omega square. Numerator must be s. Then only we can understand that it is cos. Then only we can understand that it is cos. Now the second question. Let's take the second question as Laplace transform of sine of 2t plus theta. Sine of 2t plus theta. What to do, ma? Expand it. That theta may be any degrees, 30 or 40 or 60 or 100 or 120, 180, 360. We don't know. That may be expand it. Sin a cos b plus cos a sin b. You know sin a plus b formula. Laplace transform of yes sin a. Yes. Laplace transform of sin a cos b plus cos a sin b. Laplace transform of yes sin a cos b plus cos a yes sin b. Yes, those are constants. Now you can write. Very easily. Cos theta is constant. Why? Because it's a value. Then what we are going to get? Omega by sine, brother. Sine means what? Numerator omega. Omega by s square plus omega square plus sine theta into yes. Come on. This is yes as it is cos s by s square plus omega square. This is the answer. Done. Answer done. Then go for the next question, please. Next question. That is the third question. That is find inverse Laplace transform of 1 by s square plus 2. Within 30 seconds, I want answer from you, brother. Within 30 seconds, 1 by s square plus 2. Look at it. In the denominator, s square and constant no s term. In the numerator, we have a constant. Means definitely it is sine. But does it is in standard form? No. Let's convert into standard form. Yes, that implies L inverse of yes. L inverse of solution. Yes, I'm doing the solution here. Come on. This is the question. Yes, sir. Solution. L inverse of. Let's get into standard. What is the standard? Omega by s square plus omega square is standard. 1 by s square. Let's write it as root 2 square. How much is omega? Root 2. Does it is here? No. Multiply and divide. Multiply and divide. Then what is the answer? 1 by root 2 into yes sine root 2t into u of t. 1 by root 2 into sine root 2t into u of t. Done. Yes or not? That much simple it is writing inverse Laplace. Convert into standard. Let's take the next question. Inverse Laplace of s by s square plus 11. S by s square plus 11. What is the answer, boss? What is the answer? Yeah. Now let's convert into standard. S by s square plus root 11 square. S by s square plus omega square. What is the answer? Cos omega t. Cos of root 11t into u of t. Done. Cos root 11t into u of t. Done. Yes or not? Yes. Let's go for the next question now. Let's go for the next question. Next question is yes. Inverse Laplace transform of s plus 1 by s square plus 3. S plus 1 by s square plus 3. Split it. S plus 1 by s square plus 3. Split it. How to split, sir? How to split? It is very simple. It is very simple. Yes. L inverse of what it? S by s square plus 3 plus L inverse of 1 by s square plus 3. Does these things are in standard? No. Make it into standard. Just multiplying and dividing a constant does not affect our analysis. Okay. S by, come on, s square plus root 3 square, s square plus root 3 square. L inverse of here 1 by root 3 I will multiply into root 3 by s square plus root 3 square. This 1 by root 3 I can take outside. This 1 by root 3 I can take akka outside. Therefore, what we will be getting? That is equal to what we are going to get? S by s square plus omega square. What we are going to get? Cos omega t. Cos root 3t into u of t plus 1 by root 3 into yes 1 by root 3 into yes come on man sin root 3t into u of t. Done. This is about making Laplace and inverse Laplace of sine and cos. Let's see few more examples ma. Let us see few more examples. Yes. Now find inverse Laplace transform of s by s plus 1 whole square plus 3. Yes. Here, what are the things that are present? What are the things that are present? Observe it. S by s plus 1 whole square plus 3. Now, this s is having shifting in the denominator in frequency s plus 1, but in the numerator it is not having. A shifting is said to be a perfect shifting if all s terms are having the same shifting, right? Yes, I'll repeat the statement. A shifting in frequency is said to be perfect shifting if all S terms are having same shifting. In time domain also, all T terms must have same shifting. Here, so what some people will do is they know A plus B whole square formula. Everyone knows. They will expand it. What you will get? Nothing. You are going to get. See, try to convert the given into a standard form, known standard form. Then answer will be easy. See, some people will ask me, sir, how to get the idea easily? Sir, you are getting the idea very fastly. How we can get very easily? See, the only point behind getting the idea is we have some standard forms. Convert the given signal into the standard, then answer will be very easy. I told you, not more than 2 steps we will take, not more than 2 steps. Simplification 1 step, answer another step. Yeah, come on here. I'm writing answer here. Observe. L inverse of. This is not having shifting, but this is having shifting. I'll do one thing. I'll give the shifting. S plus 1 minus 1 by, come on, S plus 1 whole square plus root 3 square I'll write. Understood till here? Come on, you have to understand. Very simple mathematical calculations. Separate it. L inverse of S plus 1 by, come on ma, S plus 1 whole square plus root 3 square. Yes, minus of L inverse of 1 by S plus 1 whole square plus root 3 square. Done till here? Yes or not? Here if you observe, sir, what we got by doing this, shifting is there in the numerator also. All S terms must have the same shifting. Yes, no, come on here. Answer will be, I'm writing the answer here. Plus 1 is there. In frequency domain, if S is having some addition, S variable is S, not S square, not S cube, not root S. S is having some constant, either in addition or subtraction. Then in time domain, what we can understand, there is exponential multiplied. Here it is plus 1 means there it is what, minus 1. So exponential, negative exponential, therefore that is equal to e power minus t. I can write. Once if we wrote e power minus t, what we are left with is L inverse of S by S square plus root 3 square. Yeah, because of that shifting, we wrote e power minus t outside. Shifting is done. I told you. See, in 2 ways I told you. One way is forget about this plus 1. Yeah, first let's go in that way what we discussed previously. Yes. Forget about this shifting. Then what is the signal? S by S square plus omega square. Forget about plus 1. Plus 1 is shifting. Forget about it. S by S square plus omega square means what? Cos root 3t into u of t. As there is shifting here with plus 1, instead of that we are going to get what? E power minus t. In frequency domain, if there is shifting, in time domain we will get exponential with opposite sign. Yes, done. This first part is done. In the second part, omega by S square plus omega square should be there, but there is no omega here. Multiply with omega. Yes, divide with omega. I am writing over here minus 1 by root 3 into, yes, here how many S terms we have? Only one S term, that is having shifting or not? Yes. Because of that shifting, we will write e power minus t. Yes. Or you forget about that shifting. Plus 1 you forget about. What we have? Omega by S square plus omega square. What is that? Omega by S square plus omega square. Sine omega t was sine of, yes, root 3t into u of t. Because of that shifting, we got this e power minus t. Then this much simple we can find inverse Laplace transform. This is we are going to solve many problems how to find inverse Laplace transform very easily. Now let us discuss this one. Let us discuss this question. Find inverse Laplace transform of 1 by s into s plus 1. S into s plus 1. How to find it? First of all, we have to find the partial fractions. After finding partial fractions, we can get the inverse Laplace transform very easily. How to find partial fractions? You will do like this. This is your method. A by s plus b by s plus 1. Simplify it, find a and b, substitute it, and you are going to get a inverse Laplace transform. This is your method. How you are going to find a and b? What you do is you simplify and compare with that numerator and solve some equations what you are getting. Then you are going to get a and b. I will give you a shortcut method of finding a and b. That is very simple once you habituate. See, here one point, some people what they feel is their method itself is good, means simplifying it and comparing with that one and getting those equations and solving, that is good, they will feel. But Once you learn this method, this is going to be very, very good. But learning this method will take some small amount of time and your dedication. Come on, brother. You have to put your effort here to understand this one. Later, this is going to simplify all your problems in a very easy manner. Okay, come on here. What is my method? General method, everyone knows. I'm not going to do that, please. What is my method? So I'll write like this. I'll write like this. See, partial fractions, right? We have to find partial fractions. Come on. I'm giving you a new method. How to find partial fractions? L inverse of, write S here, write S plus 1. Do not put A and B. Do not put A and B. Write your function here. Write your function here. 1 by S into S plus 1 is the function. Total function. What you want to find? The numerator of S you want to find. This S numerator I want to find. Okay. Here I am having S. Here I am having S plus 1. S numerator I want to find. Whose numerator you want to find? I am repeating it. Whose numerator you want to find? First of all, make that equal to 0. Then how much I got? S is equal to 0. Take that value and substitute in this one by closing this one. Again, yes, I'll repeat it. Observe. Whose numerator you want to find? Make that equal to 0. You'll get some value. Yes, you got some value. Substitute that one in the original function by closing whose numerator you want to find. Our concentration is only on whose numerator we want to find. We want to find this numerator. So first of all, mask it. Imagine that is not there. Make that equal to 0. You got S is equal to 0. Substitute that one in the remaining function. How much I am going to get? 1 by 0 plus 1. How much it is? 1. So that A is equal to 1. A is equal to 1. Yes or not? Come on here. You can do it. You do and get back to us. Okay. I want to find this numerator. What to do? Come on. I want to find this numerator. What to do? Make this equal to 0. If I make this equal to 0, how much I am going to get? S plus 1 is equal to 0. S is equal to minus 1. After this, what I have to do? Mask this. Yeah. Whose numerator you want to find? That one you mask. Come on, ma. Whose numerator you want to find? 1 by S into S plus 1. You mask this. Imagine that is not there. In this, after removing that, put this value. After making this one is equal to 0. S is equal to what? Minus 1. 1 by minus 1. How much it is? Minus 1. Done. It is minus 1. This much simple. It is how to find what partial fractions. See, you may be thinking, sir, this is looking difficult. What we learned in BTech is or in our graduation or at intermediate is looking easy. As you are habituated with that method, and this is a simple problem that may be looking easy, but once you got habituated for this one, without pen paper, just by looking at it, you must be in a position to tell the values of A and B. Now apply inverse Laplace. What you are going to get? What is inverse Laplace of 1 by S? U of t, brother, minus 1 by S plus 1. I told you first of all 1 by S. What is that? U of t. There is frequency shifting. E power minus t. That's it. 1 by S plus 1. 1 by S U of t. S is shifted with 1 unit. Therefore, in time domain, you are going to get e power minus t. Yes. Let us go for the second question, please. Let us go for the next question. Yes. Inverse Laplace of, I can say, 1 by S into S plus 2. Just for the purpose of practice, I given this question. Yes. First of all, what to do? Find partial fractions. Yes, I am writing partial fractions. Observe here. At least by this time you must be in a position to answer, please. Okay. We should not take a good amount of time for doing these small calculations. What to do? Make S is equal to 0 first. How much I got? S is equal to 0. Substitute by closing this one. How much it is? 1 by 2. How much it is? 1 by 2. Make this equal to 0. S is equal to minus 2. Substitute in this by masking this one. How much I got? Minus 1 by 2. That's it. Therefore, its inverse Laplace will be 1 by 2 into U of t minus 1 by 2 into e power minus 2t into U of t. Done. That much easy it is. Finding inverse Laplace. Let's go for the next question, brother. Next question. Find inverse Laplace transform of 1 by S into S plus 2 whole square. This is very important. First of all, how to write its partial fraction expansion is very important. Come on here. Now, L inverse of, I'll be writing like this. Yes, this will be, first one will be S plus 2 whole square. Next, again, we have to write S plus 2. Okay, means square is there, that s plus 2 will come for 2 times. One is with the total. After that, after removal of 1 power. Suppose if it is s plus 2 whole cube, s plus 2 whole cube, s plus 2 whole square, s plus 2. If it is s plus 2 whole power 4, s plus 2 whole power 4, s plus 2 whole cube, s plus 2 whole square, s plus 2. In that way, we have to expand. Now, how to find this one? How to find this one? That is very easy. Same as the previous method. Make this equal to 0. Yes, make this equal to 0. Come on. How much it is? S is equal to 0. Take this and substitute by closing this one. How much you got? 1 by 4. Yes or not? 1 by 4. Come on. Make this equal to 0. Substitute in this one. After masking, whose numerator you want to find? Okay. 1 by 0 plus 2 square. How much it is? 1 by 4. That is done. How to find this one? This is also very easy. This is also very easy. Make this equal to 0. How much I got? S equal to minus 2. Mask this one and put there. How much I'm going to get? Minus 1 by 2. Minus 1 by 2. That is very easy. That is very easy. Now, how to find this one? How to find this one? We cannot do in the previous way, because if I mask 1 s per 1 power, means 1 s plus 2. One more s plus 2 will be there. If you make this equal to 0, you are going to get s equal to minus 2. And after masking this square, if you put s is equal to minus 2 in this total, that is going to become equal to 0. 1 by 0 will be infinity. That process is not correct. How to find this one? How to find this one? This one can be done with the direct inspection method. What is the direct inspection method? You just simplify it. Means only we will see s square terms. We will see s square terms. How much I am going to get here? How much I am going to get here? 1 by 4 into, yes, s square. Come on, man. 4 plus 4s is this one here. What I'm going to get here? Minus 1 by 2s plus something we don't know into what I'm going to get? S square plus 2s equal to how much I should get? Observe here, please. This is 1 by 4 into s plus 2 whole square. S square plus 4 plus 4s. This is minus 1 by 2 into s plus this is s into s plus 2. Yeah, 1 s plus 2 is not there. 1 s plus 2 will come from here. S is not there. Therefore, s into s plus 2, that is s square plus 2s. What we taken there? Equal to 1. Only numerator we are comparing. Only numerator we are comparing. So, what we have here? 1 by 4 s square. 1 by 4 s square. Here s square is there. How much should be? Minus 1 by 4. Answer should be minus 1 by 4. In this way, with a direct inspection, you can do it. Means just to compare only one. See, you may be thinking, sir, I'll consider this one as A, this one as AB plus C, this one as BC plus D. That is nonsense. It becomes very lengthy. But with this is only the simplification step what we have to take here. This is only the simplification step what we have to take up here. In this way, we can find. Suppose we have s plus 2 whole cube. We can find. So not only this way, we have another way also to find this one. We have another way also to find this one. What is that another way? We will see. What is that another way? We will see. The problem is 1 by s into s plus 2 whole square. The same problem we'll do in another way. Yes, same problem we'll do in another way. That is L inverse of 1 by s into s plus 2 whole square. In another way we are going to do. What is that another way? Let's see. Come on. First, the expansion will be same. Expansion we have to write in this way. 1 by s plus 2 whole square plus s plus 2. This one directly we can get how much we got previously, or s is equal to 0. If you substitute, how much you're going to get 1 by 4. Now, how to get this repeated, what you called repeated functions numerator you want to find? Let's take this one as k1. Let's take this one as k2. Let's take that one as k1 and take it as k2. Now, how to find k1? How to find k1? The formula is like this. K1 is equal to d I power minus 1. I power minus 1. What is that? I will tell you. By d s I power minus 1 of f1 of s. F1 of s. So ki I call ki, not k1, ki. So once you understand this formula, that is going to be very easy. Once you understand this formula, I'll be writing once again. See, I'll be writing here once again. Come on here. Ki is equal to 1 by I minus 1 factorial. Sorry, previously I forgot this one. 1 by I minus 1 factorial. D I power minus 1 by d s I power minus 1 into f1 of s. F1 of s. So this is the formula. How to execute this one we are going to see. Okay. Ki means ki equal to 1 here. I equal to 1 here. 1 by means we want to find k1 here. We want to find k1. K1 is equal to 1 by 1 minus 1 factorial s d power 1 minus 1 0 by ds power 0 of f1 of s. First of all, what is this f1 of s? f1 of s is this one. f1 of s is equal to here I'll tell you equal to 1 by s. Sir, how you wrote f1 of s is equal to 1 by s? Remove the repeated quantity from the original function. Okay, what is the repeated quantity? 1 by s plus 2 whole square. It is having s plus 2 whole square in the partial fraction expansion and s plus 2. So this one has to be removed from the original function. Suppose here it is f of s is equal to s plus 1 by s plus 2 whole cube into s plus 3, suppose say. Here f1 will be s plus 1 by s plus 3. This s plus 2 whole cube will be removed. f1, I am writing about f1. Understand carefully, please. Understand carefully. f1, or if you want f1 to give in standard form, f1 of s is equal to that s plus p1 whole power r. R means which is repeating. That one, see, this s plus 2 whole square is s plus p1, where p1 is 2 here, p1 is 2 here, this r is also 2 here, into f of s. What is f of s? 1 by s into s plus 2 whole square. So this will get cancelled. This one will cancel. You have f1 of s is equal to what? 1 by s. I'll be writing in the next page. Come on here. f1 of s is equal to s plus p1 whole power r into f of s, where let me define f of s also. F of s is equal to subnumerator by s plus p1 whole power r into denominator, where this is not having any repeated, If that is also having any repeated, that is another problem again. Yes or not? Yes. So here s plus z1 and so on by s plus p2 and so on. Yes or not? Now let's find k1 and k2. Let's take the problem once again here. L inverse of 1 by s into s plus 2 whole square. Yes, this is s. Let's write L inverse here. This is equal to L inverse of s plus 2 whole square. This is s plus 2 here. Yes, this we got it as 1 by 4, and we taken this one as k1, we taken this one as k2. What is ki we wrote? Why I am writing these many times? So that you will understand, you will remember, you will execute. That's why I am doing again and again. K is equal to 1 by I minus 1 factorial. Yes, d I minus 1 by d s power I minus 1 into f1 of s. Here, what is f1 of s? Here, what is f1 of s? Where f1 of s is equal to how much? 1 by s. Now, k1 is equal to 1 by 1 minus 1 factorial. Yes, derivative d power 0 means no derivative. There is no derivative. 0 derivative means no derivative. Directly f1 of s. How much it is? f1 of s is 1 by s. How much we are going to get? At s is equal to what? At s is equal to minus 2. That we should not forget. Yet s is equal to minus 2. Because this one to be equated to 0 to get s is equal to p. S plus p1 we wrote previously. If you observe, s plus p1 we wrote. Yes, this is p1. Yes, this is p1. Yes or not? This is p1, and we wrote previously. That is here we forgot s. Here I have to write at s is equal to p1. Come on here. So k equal to how much we got? K1 is equal to minus 1 by 2. K1 is equal to minus 1 by 2. Let's do for k2 also. We have to get the same answer previously what we got by using general what you call the simplification. K2 is equal to 1 by 2 minus 1 factorial. I is equal to 2 here. This is I, please. K1, K2, I is equal to factorial. D power 2 minus 1 derivative, first derivative, by d s power 1 means ds of what? 1 by s. 1 by s. At s is equal to what? Minus 2. So K2 is equal to 1 by 1 factorial will be 1. So what it is minus 1 by s square. Minus 1 by s square. At s is equal to minus 2. What we got? K2 is equal to minus 1 by 4. Observe whether the same answers we got or not previously. K1 is equal to 1 by 4. Sorry, initial one is 1 by 4. K1 is equal to minus 1 by 2. K2 is equal to minus 1 by 4. Observe here. Previously, with general method we got. Yes, we got the same. But I feel this method is simple when compared to that derivatives method. Okay, and moreover in gate examination up to second order, at most third order, that is enough. He is not going for fourth and fifth orders. Some people have in mind, sir, if it is fourth order, it is going to be very big. How to calculate? Don't worry, brother. Gate examiner will check your ability to solve the problem logically. He do not want to waste your time. He will give always a logical question. If you are able to find the logic within seconds, that question can be solved within 1 minute. If you are not in a position to get what you call the logic, it will take some hours. Gate examiner always give the question to check your mental ability, your logical ability, not your. You don't want to waste your time, please. If you get the logic, you can get within no time. Okay, that type of questions only will be asked. Do not keep unnecessary doubts in your mind. Okay, come here. So this is the way how to find partial fractions of a repeated. Let's go for one more question. Yes, come on, ma. Next question I'm taking here. That is an example. Yes, find L inverse of 1 by s square plus s plus 1. S square plus s plus 1. Good question, ma. Good question. What's your idea? What some people will give an answer to me is, sir, do one thing, find two poles, means not poles, please, as you don't know about poles, make it into factors, two factor, s plus a into s plus b, and find partial fractions and apply inverse Laplace. But does it get two perfect factors without complex numbers? No. Why? If you see, it's a b square is less than 4ac. What is b square? 1. 4ac is 4. 1 minus 4 means j root 3 are going to get. It will not give two perfect numbers, two real numbers while factorization. So means splitting into two parts and writing partial fractions is going to be very difficult for us. Yeah, you can do this in mathematics. In some of the textbooks, that those mathematicians wrote in this way only. So they split this one as some s plus 1 by 2 plus j root 3 by 2 into s plus 1 by 2. For example, I'm writing this. I don't know what are the factors of it until and unless I found. Yeah, you find it. You can get the factors. Okay, minus j root 3 by 2. They will write in this way 1 by. After that, partial fractions they will get, and that is nonsense. It is the lengthiest method, I feel. Never in control systems, not only in control systems, in engineering we will follow that. Never in engineering we are going to follow that. That is very simple to do. Okay, how to do it? I'll tell you. This is s square plus s plus 1 whole square. Arrange in shifting format. How to arrange it in shifting format? See, all of you know a plus b whole square formula very well, right? Now let's write this one in the form of a plus b whole square. That is, s is a, b is not 1, please. B is not 1. S is equal to a, you take from s square. From s square is equal to a square. S is equal to a, we take 2ab equal to s. 2ab equal to s we are taking, not b equal to 1. Sir, why we are taking 2ab is equal to s? A plus b whole square in this format I am writing, where a square plus b square plus 2ab. Okay, but b is not 1 I am taking. Why, sir? Why you are not taking b as 1? Constant I can add or subtract or multiply or divide. I can do anything. But s term is somewhat going to be difficult. That's why a plus b whole square is equal to a square plus b square plus 2ab. S square is equal to a square. Therefore, s is equal to a, or a is equal to s. A is equal to s we take. Yes, that implies a equal to s we are taking. Now a is s. Come on, a is s. We don't know b. S gone. So b is what? 1 by 2. B is 1 by 2. Now write this one as s plus 1 by 2 whole square. Now observe here. Sir, we wrote it as s plus 1 by 2 whole square. Okay, done. No. Expand it. S square, okay. 2ab. 2a. 2s into 1 by 2. Yes, okay. This is tallied. But this is not tallied. Why? B square is what? 1 by 4 we are getting. But how much I want? 1. For in 1 by 4 is there with us. How much we are not having? 3 by 4. Therefore, plus 3 by 4. Now, this one and that one both are exactly equal. This one, what I'm showing here, that one both are exactly equal. This is the procedure, please. So, we are not kids to do like this. Just by looking at it, we must be in a position to get the value of a and b. So, b, we should not take it as 1. What happens if we take b as 1? What happens? S plus 1 whole square. Come on here. S plus 1 whole square. Okay. S square plus 1 plus 2s. What I have extra? 1 s is extra. Okay. We'll write that one also. Yeah. Now, this one and this one also both are exactly equal. This and this, all three are exactly equal. But which is useful for us? Let us see. If you observe this 3 by 4, I can write it as, how much here we have? 1. The 3 by 4 I can write it as a root 3 by 2 whole square. Yes, I'm writing it. Observe. L inverse of, please, L inverse of 1 by s plus 1 by 2 whole square plus root 3 by 2 whole square. This is having like a s square plus omega square with shifting. Come on, brother. Very important to understand. S square plus omega square. Sir, in the numerator omega is not there. Multiply with omega. Divide with omega, boss. L inverse of. Yes or not? Now answer is what? 2 by root 3 is outside. 2 by root 3 outside. Why? Because I multiplied with root 3 by 2. I have to compensate it. I wrote outside omega by s square plus omega square. I told you number of times that s plus whatever it is, you forget to put it for time being. S plus whatever it is there, forget to put it for time being. But all s terms must have same that 1 by 2 or 1 by 3, 1 by 4, whatever it is, or s minus 1 by 2 or minus 1 by 4, whatever it is, all s terms must have the same. Here only one s term plus 1 by 2 is there, forget about it. Omega by this 2 by root 3 I wrote outside, that is done. L inverse of root 3 by 2 by s plus 1 by 2 whole square plus root 3 by 2 whole square. Yes or not? Come on. It's very easy to understand. Now 2 by root 3 into omega by s square plus omega square plus omega by s square plus omega square. What does it is? Inverse Laplace sine. Come on. Root 3 by 2t into u of t. Sine root 3 by 2t into u of t. S is having some shifting. Instead of that, we are going to write e power minus 1 by 2t. Frequency shifting in time domain, we are going to get a negative. Here positive, there negative. Here negative, there positive. Time shifting, same sign. So time shifting, same sign. Now that is this one. Now we taken this one also, right? We taken this one also. Observe this one. What can we do this one mean? Nothing. S plus 1 whole square minus s. Is there any identity? This type of identity we have to compare and to get inverse Laplace? No. So taking b is equal to 1 is a foolishness, because here no b. B is equal to 1 if you take, you'll get s plus 1 whole square minus s. This type of standard formula we do not have to get inverse Laplace. So in this way we can get very easily. Let us solve one more problem. This is very simply I'm going to solve this problem. Example. Yes. L inverse of 1 by, come on ma, s into s square plus s plus 1. S square plus s plus 1. This is very simple. Let me show you how we are going to solve. Very easily. Yes, L inverse of general expansion. Yes, and s square plus s plus 1. Finding partial fractions here, it is going to be dead easy. What you do is a b plus c, a bs plus c. All that you write, you compare, you do it. Yeah, you get that. But being an engineer, we must be very intelligent to get these answers in a smart way. Okay, smartness is very important here. How to get this one? Put s is equal to 0, boss. Put s is equal to 0. Closing this one. How much I got? 1. Here onwards, partial fractions just like that I'll do. You must habituate for that. Put s is equal to 0. Make this again. I'm repeating that procedure. Make this one equal to 0. How much I got? S is equal to 0. Mask that factor here and put that s is equal to 0. What you got in this one? How much I got? 1 by 1 plus 0 plus 0 plus 1. How much it is? 1. Now we want to find this. Very simple way. Imagine that something is there. If I simplify this one again, that this must be equal to that one, right? If I simplify this one again, this must be equal to that one. I'm simplifying it. Yes. Come on, I'm simplifying it. Observe all of you how I am simplifying. Observe. Yes, your observation is needed here. Come on. What is this? This side we are going to get what? S square plus s plus 1 plus s into something is equal to 1. Come on. I am assuming that something is there over here. I don't know what that value. I have to find that value. This into this plus this into this equal to that numerator 1. Now, for this one to be equal to 1, come on, what I should have here? Minus s and minus 1. How sir? S square is there. For that s square to get cancelled. Why? Because here s square is not there this side. For that s square to get cancelled, 1 minus s I have to keep here. S into minus s will be minus s square. Okay, done. Here one s is there. Here s is not there. To get that one, I am putting here minus 1. So here what I have to keep? Here I have to keep minus s minus 1. This method is called as a direct inspection method. What does it mean? What is its name? Direct inspection method. what we got like this. Come on, that is equal to L inverse of 1 by S minus of, I'm taking minus common, S plus 1 by S square plus S plus 1. Now we got this Laplace transform easily. That is, what is that, ma? U of t minus inverse Laplace transform of S plus 1 by S square plus S plus 1. Does this can be factorized? No, we can't get to two real factors for that. We saw the procedure previously, right, in the form of a plus b whole square. Suppose if it is like this, s square plus 3s plus 6 is there, s square plus 3s plus 6 is there, or s square plus 5s plus 6 is there. I can write this one as s plus 3 into s plus 2, s plus 3 into s plus 2. Yes or no? So this is very easy, boss. This is very easy. Okay. If I get this type of two real factors, again, yes, a plus b. You can find the value of a and b very easily. That's not a matter. But here, that cannot be factorized with real numbers. Therefore, what I told you, arrange in the form of a plus b whole square. So that is equal to u of t minus L inverse of s plus 1 by, we did previously, how much we got? S plus 1 by 2 whole square plus root 3 by 2 whole square. S plus 1 by 2 whole square plus root 3 by 2 whole square. But if you observe, there is one what you called see, there is no mistake here, but there is one difficulty for us here. What is that difficulty? Here this is having shifting of 1 by 2, but whereas this s is having shifting of 1, what to do? Make the numerator, can you change this shifting? Not possible, but I can change the numerator shifting. How can I change the numerator shifting? That is equal to u of t minus L inverse of, I can write it as s plus 1 by 2 plus 1 by 2. Not a matter. Adding a constant means not splitting that constant. Okay. S plus 1 by 2 whole square plus root 3 by 2 whole square. Na? Root 3 by 2 whole square. Yes or not? That is equal to u of t minus L inverse of, split like this, s plus 1 by 2 by s plus 1 by 2 whole square plus root 3 by 2 whole square plus this bracket is there, 1 by 2 by s plus 1 by 2 whole square plus root 3 by 2 whole square. We close this bracket. Let's go to the next page. Yes, I'm writing here, that is equal to u of t minus L inverse of s plus 1 by 2 by s plus 1 by 2 whole square plus root 3 by 2 whole square minus L inverse of, I have 1 by 2 here, but what I need root 3 by 2, as I multiply with root 3 by 2, divide with root 3 by 2, that is nothing but into 2 by root 3, s plus 1 by 2 whole square plus root 3 by 2 whole square. Yes or not? Yes. Then come on, here we will write the complete answer. U of t minus, here plus 1 by 2 plus 1 by 2 is there. In S domain, S is having some shifting. In frequency domain, we are going to get e power minus 1 by 2t. Done. 1 by 2 is not there. Forget about 1 by 3. 1 by 2. 1 by 2. What we have? S by S square plus omega square. What does it mean? Cos of omega. How much it is? Root 3 by 2 into u of t is mandatory, boss. No u of t, no meaning. Yes. Minus of this 1 by 2, this 2 gone. 1 by root 3 I will get outside. What I have? There is some shifting of e power 1 by 2. That's why I taken e power minus 1 by 2t. Now root omega by s square plus omega square. What does it mean? Sine. Then how much we are going to get? Sine root 3 by 2t the whole into u of t. So in this way we can get the answer very easily. Okay, so it looks somewhat big. Only simplification. If you are good, see, for your understanding sake, I taken these many steps. Otherwise it is a matter of only 2 steps or at most 3 steps. So this is about finding Laplace and inverse Laplaces of some standard signals. We saw impulse step, ramp, parabolic, and sinusoidal, exponential, time shifting, and frequency shifting. We are left with initial value theorem, final value theorem, and its limitations. We can't apply initial value theorem and final value theorem in S domain directly to a question if that some condition has to be satisfied. that we have to discuss. After that, we have integration property and differentiation properties. See, in time domain, integration is there. In frequency domain, what we are going to get if we apply Laplace transform. Differentiation in time domain, frequency domain, and with the initial conditions. After this, we have to see RLC elements in time domain and frequency domain. Entire control systems. Most of the times, I'm going to take the example of networks in S domain. Therefore, you must have good knowledge of representing RLC elements in frequency domain with initial conditions and without initial conditions. With that, we are going to complete all Laplace basics. That's it, not the chapter. Please, chapter is very big chapter, first chapter. Lot many basics are there. Once we are good at first chapter, later chapters can be understood very, very easily.